Okay, good. So we've obeyed two of our axioms. The next axiom that we're going to consider is A3. So, let me just change that. Good. So now consider A3. And I'm going to consider A3 at x is equal to 0 and a is equal to x. Okay, so remember, these are four vectors. So let me just put the mu's there maybe. So let's see what this says. So we've got phi of x plus a, that's 0 plus x. This is just going to be phi of x, and this will be equal to e to the I, a dot p, now a is x, so this will be x dot p. I will have phi of 0, and then I will have e to the minus I x dot p. Now, okay, so first of all, you might have wondered what was I thinking to consider x is equal to 0 and a is equal to x. Well, you see, it's because on this side, because I'm plugging 0 into phi, all the x dependence, so all x dependence is known. Okay, does that make sense? I've got x's appearing in the exponents, but I know what function the exponential is, and I've got phi of 0. So on the right-hand side of this equation, all the x dependence is known. On the left-hand side, I've got the functions fk of x and f star k of x. So I'm going to be able to actually determine what those functions of x are by studying those equations. So I'm going to determine all of the x dependence in my field. Let me explicitly write out what this equation says. So phi of x, well, that's easy. That's going to be the integral d3k over 2 omega k 2 pi cubed. And then we've got fk of x alpha k plus fk star of x alpha k dagger. Okay, and this will be equal to. Now, when I act with e to the minus ix dot p, let's take a look. That's a number, that's a number, that's a number. So everything that I've outlined in blue is a number, and I can pull operators through the numbers. The only things that are operators is the alpha k and the alpha k dagger. So when I multiply by e to the ix dot p, I can pull it all the way up to alpha k, all the way up to alpha k dagger, because I'm just pulling it through numbers. And when I multiply by e to the minus ix dot p, I can again pull it all the way up to the alpha k and all the way up to the alpha k dagger. I'm always allowed to pull operators through numbers. Okay, good. So let's do that. So here's the number. Nothing gets caught on the number. Over 2 omega k, 2 pi cubed. And then we've got fk of x. We've got an e to the I x dot p. We've got alpha k e to the minus I x dot p plus, and then we've got let's see. Sorry, I made a mistake. There should be e to the I x dot p phi of 0. Okay, so because it's phi of 0, I should evaluate fk at 0. Okay, so this 0 sitting there is this 0 sitting here. And then for the second term, I've got fk star. This will again be 0. Same 0. And then I've got e to the I x dot p alpha k dagger e to the minus I x dot p. Okay, great. So if I compare the two sides of this expression, okay, it's quite clear that this term is going to be equated to that term, and taking the dagger of that, this term is equal to that term, okay? So actually only equating the green underlined term to the green underlined term, that's enough to satisfy this axiom, because the blue underlined term equated to the other blue underlined term, well, that follows by taking a dagger. So all that I want to do now to satisfy this axiom, I want to say fk of x alpha k is equal to fk of naught e to the I x dot p alpha k e to the minus I x dot p. And if I can satisfy that condition, then I have used up axiom 3. So that would be great. Okay. Sorry, let me just clear a little bit of this. Good. Okay, so the thing that I really want to evaluate is what's sitting over here. That's the thing that I want to evaluate. So I'm going to study that in a particular basis. Okay, so what basis am I using? So here's a basis for the Fock space. It's the set of states K1, K2, all the way up to Kn. These are states with a definite energy and momentum. So what do I mean by that? Well, if I take the Hamiltonian and I act on this state, it just gives me the sum of energies. So it's omega k1 plus omega k2 plus, keeps going up to omega kn onto the state. And if I take the momentum operator and I act on the state, it will just give me the sum of the momenta. Okay, so you've seen the construction of these Fock space operators, Hamiltonian and momentum. We constructed those in a previous chapter. And now we're going to use this basis to perform our next calculation. You get a complete basis when you consider states for all possible values of n. So no particles, one particle, carrying on up to infinite number of particles. And the momenta and energies are allowed to range freely. That gives you then a basis for Fock space. What we're going to do, we're going to study e to the I x dot p on alpha k. In fact, you know what? This is not the equation that I want to study. It's slightly simpler to study this equation. I'm going to complex conjugate fk. I'm going to include a dagger sitting here. So that's that blue underlined term. I'm going to complex conjugate here. I'm going to include a dagger here. And that is the equation I want to consider. So this is the blue underlined equation. So let's call this the blue equation. That's the one I want to study. Okay. Alpha k dagger e to the minus I x dot p. I'm going to act on an arbitrary state inside this basis. So n could be anything. The momenta could be anything. Okay, we'll continue in a moment.